Welcome to this conference. Thank you for being here. So in today's session, we are going to talk about Jakarta Data. It's a standard data access for SQL and NoSQL databases. So this is a joint talk by Werner and myself. Werner.
Yeah, so I'm an open source activist. I lead many open source projects at Eclipse and elsewhere. I'm the committee representative in the Jakarta EE specification committee. And I also wrote a book with others like Arjan, Times. Many of you will probably know, especially those who are involved in Jakarta EE.
Yeah, I'm Emily Jiang. I'm from IBM. I'm the cloud native architect. I mainly work on the open source projects, microprofile, Jakarta EE, and Open Liberty. So my the main focus is cloud native. So it's by the way, tomorrow I also have a talk about monoliths to serverless. So if you are interested, please come to my next talk. So let's get started.
Do we have a clicker or?
Oh yeah.
Okay, so what are the trends in 2023? Of course, in the keynote we already heard about a few, so I will go through some of the items and trends a little faster. More customers are going online. The cloud is connecting everything. And as we heard just before with the terminators, big data gets even bigger. And many applications move to the cloud, either a private cloud or a public cloud. And almost everything is available on a mobile or wireless device as well. So that creates some challenges. Most of the projects nowadays work in an agile fashion. We need high performance and availability to manage huge data volumes. And in many cases, NoSQL can be useful. But of course, there are also companies and applications that still require relational databases. That's why we're going to show you what the differences are, and all of these frameworks, especially Jakarta Data, allow you to access both. So what are the advantages of NoSQL? It handles large volumes of data at usually high speed. You can store unstructured, semi-structured, or structured data. It's usually easier to update schemas or fields. I guess. How many of you use NoSQL databases? Okay. And the rest uses relational databases? Yeah, so I guess some of you probably know, especially if you're in a large company, I also work in the public sector right now, helping them to get cloud native, and there it can be way tedious if you want to change the name of a column or introduce a new column to an Oracle database. It sometimes takes way long, and that's where NoSQL systems can often be faster, even in public companies. It's developer friendly, and it takes advantage of the cloud to deliver, in ideal cases, zero downtime. So we are comparing several popular Java-based or JVM-based persistence frameworks. The JVM can usually cope with a heavy load. There are many persistence frameworks, so we pick the most popular ones. And also some of them are involved in Jakarta data standardization. So in the future, you should be able to switch implementations from different vendors. And yeah, we'll see which one performs best for your case. But of course, when Jakarta Data is final and standardized, you should also have an advantage of being able to switch between different vendors and implementations. It will normally take quite a while to compare all of them, but we condense them so you can see the most important points in this session. So NoSQL databases are usually not structured or not fully structured base. And there are 4 or actually 5 different types. The first one is key value, with examples like Amazon S3 or Dynamo, Redis, or Hazelcast. Then there are column-oriented ones. Those are probably closest to relational databases, and sometimes you also find systems that support both column-oriented NoSQL and traditional relational databases in one server. There are document stores like MongoDB and others. Graph databases. Neo4j is probably the most important one and the most well-known. And then, as I mentioned, there are actually 5, but time series is a bit special, but it allows you to almost literally travel back in time, like Back to the Future or Terminator, as we just saw earlier. And then there are also combinations like OrientDB that supports both graph and document. Couchbase allows you to use either key value or document. And ArangoDB supports up to 3 different types in one system and in one application. So what are the main differences between SQL and NoSQL? Here are the relevant terms. As you can see, there are some like column that are used by more than one and are also used by the column-based system for obvious reasons, while others like the vertex or edge are specific to only graph databases. We just heard about base and acid, so I'll skip for this one faster. Then there's the so-called CAP view. It stands for consistency, availability, and partition tolerance. And then there's also the view on how scalable a system is compared to how complex it is. And here you can see that, for example, key value systems are usually very scalable, while graph systems that store many more complex types of relationships also mean that the system can be more complex. In a relational application, we typically have the DAO layer sitting on top of standards like JPA and lower level standards like JDBC, and then the actual database. With NoSQL applications, at least until there's some standardization, the APIs are often not very compatible with each other, and it's almost like apples and pears. And if your application wants to switch, let's say from MongoDB to Neo4j, this means rewriting large parts of the application. So let's have a look at some of the persistence frameworks that are currently out there. there were approaches, especially by Red Hat, trying to tackle NoSQL databases using JPA, but of course that's not so easy because the saves can be asynchronous. There are asynchronous callbacks, the time to live, and the consistency level, and there's diversity as mentioned before in NoSQL, and JPA is usually not that easy to handle all of that. And we even took the Hibernate, I think it's Hibernate OGM, so there was a Hibernate approach, but the project has been dormant for almost up to 7 years now. So unless you have it in production and you still need to maintain it, I would not really recommend to use that. So how do all of these persistence frameworks approach databases, both SQL and NoSQL? So most of the systems have annotated entities, just like JPA. Many of them have a template pattern or mechanism in an API. And practically all of them have the repository pattern. Now let's look at how some of these use that at the moment. So Micronaut also has a still advancing Micronaut Data, and the committers to Micronaut and the contributors are actually also actively involved. So you'll hear a little more about that by Emily, but they provide input, and they also hope to adopt Jakarta Data in the long term in Micronaut Data. So here are some of the annotations that are specific to, for example, one system like the Mongo repository. The entity is annotated. There's minor differences, like it's called mapped entity here, but other than that, it looks not so different from JPA. And you can also do query by text, similar to what you saw in the keynote about SQL. Gorm was actually a heavy inspiration or almost a predecessor to Micronaut Data, because most of the creators of Micronaut were originally involved in Grails and Groovy, and also in Gorm. So just one example here. Obviously the entity looks very similar. And now let's take a look at Spring Data. It's usually quite easy, especially with Spring Boot, that you just add the desired dependency. And then here we have a MongoDB example with a document annotation, with a repository. And yeah, the controller is usually relatively easy. It just injects the repository. So that's why we left it out here. And here's an example with Neo4j, with a graph database. All you have to do is to change the dependency to Neo4j. And then you got a movie entity and a movie repository, a person entity as well as roles, how they are connected. Because in this case, the graph database allows you to have roles and relationships in various ways, so that it's more flexible, and therefore it's also more complex. So let's have a look. Here's the movie repository that extends the out-of-the-box reactive Neo4j repository. So in Jakarta Data, we also aim to support reactive in future versions, but at the moment, because there are different underlying reactive frameworks, and it's not yet fully standardized. So there are several of them, but there's no real standardization happening. So that's why we aim to do this in a future version. But for the beginning, we leave the reactive part out. Here's the annotated entity. Again, it looks very much like JPA. And the relationship between different persons. Then there's Quarkus. It supports databases after other approaches by Red Hat have been pretty much abandoned, like Hibernate for NoSQL over JPA. This one, the so-called Panache, Hibernate Panache, is more active, and it's alive, and it's also used by Quarkus. And here we see how the repository works, also injecting it with CDI. Yeah, so why standardize? Here you can see that there's multiple systems, and each of them usually requires their own API. So we aim to make the access to both NoSQL and SQL easier. I think we are already in the Jakarta Data part, so over to Emily.
Okay, thank you, Werner. So this is kind of the example about entities, and this is pretty much JPA style, and also the, I mean, you can directly inject the templates. So this is kind of Werner already discussed the different type of template, like key value, and also the kind of the document template, and etc. So the main thing for this talk is about Jakarta Data. So it's basically one already talked about all different styles and etc. Now what we really want to do is not vendor lock-in, right? You want a user standard so that you can move your application, don't need to care about which libraries you have to use. So this is Jakarta Data. So this is the GitHub repo. So check it out if you have not heard of Jakarta Data. Any of you have heard of Jakarta Data? Oh, that's pretty good. Awesome. For the ones who have not heard of it, do and click on the link and check it out. And so in this next few slides, next like 25 minutes, I will talk you through the whole thing about Jakarta Data. Hopefully, at today's session, you will find out is you can get started with Jakarta Data in 5 minutes. So this is the goal. So basically, the pattern is for Jakarta Data, we want to hide the data access layer. So that give you like an open API. So give you the API, you can directly access the backend without a need to know, how to connect with them and etc. All you want to know is just create a few classes and off you go. Let the provider of the Jakarta data to deal with all the complex. So it's basically the Jakarta data is worry about data access layer. It's directly connected with SQL or NoSQL or with some other like web services. So for you, all you need to do is basically you need to worry about write your business logic and create your repository, basically the interface. And all this like a database. Basically, you choose whether you want to use SQL or NoSQL. The implementer of the Jakarta data will basically provide all of this. So all you need to know, you just figure out this, and also you figure out that. So as simple as this. So in more details, so what you really need to know, you create your entity. So basically, a person, that's an entity, and then you create your repository. Like all the save or delete or query, and also you can perform the CRUD for the basically SQL database and some other operations for NoSQL. So this is the kind of the example here. So basically you create your entity. So this is your entity product, ID, name, and price. And you need to just create another class interface. Basically, the products extends the data repository. So this is provided by Jakarta data repository. And then basically you put in this product link to the entity. So this is the second parameter is the key. So basically the key. So it's all you need to do is create this class, and then you can directly inject this one into your like a Jakarta REST, and to perform a save and found any of the query. So one thing to say is the data repository basically is just a marker. It hasn't got any built-in method. You can just create your own method. So for creating the method, it's not like any arbitrary method. So later on, we'll talk about what kind of method name you need to specify, or any kind of annotation you need to specify. One thing to remember, you just need to create this interface. You do not need to do the implementation. So this is the beauty of about Jakarta data, is hide the implementation away from you, and basically that will be provided by the implementation of Jakarta data. So this is another example. Previously, we do a data repository. So the second interface is called a CRUD repository. So this one, basically, it come with quite a lot a method already. So you directly inherit all this method, and then you can provide any additional method you want. So for this one, there's a pattern associated with, and later on we'll talk about it. So as you can see here, once you inject this one into your Jakarta REST, any REST application, you can do save or found whatever. So the third repository is a pageable repository. The pageable repository basically extends the CRUD repository and add another class, is find out. So it's basically is when you retrieve a record, etc., you do not normally retrieve all of them, right? You retrieve one page and second page, just for the performance reasons. So this is a kind of very well used pattern, so pageable repository. Later on, we'll discuss how can you do the pageable repository. So as I said earlier, you just need to create this interface and also create a method. this method is not just an arbitrary method. You can't just say telling me and print my name and etc. Because that implementation need to be provided by the Jakarta Data implementation. So it has to work out some pattern so that it will be able to supply the implementation, call a particular method for you. So that's why you have to use the name pattern. The pattern is like you can start with save, find by, delete by, count by, and etc. So basically, also you can even do the use a keyword like, between, and etc. So here is find by name, like, and price between, and then find a name like this name pattern, and the price between mean price and max price. So you can just supply that. And the thing is, if you use that pattern, sometimes your method name is going to be super long, right? If you do a lot of queries and etc. So that's why there's an alternative. So you can use the annotation query. So here, if you want to directly do some operation, discount all, you supply this query in the basically the basically the Jakarta persistent-based query, so JPQL. So you can say, okay, update product and then set the price with this discount. And alternatively, if you want to say, okay, you can just change this name to be a different name, you can supply prom, and here you can just do the basically the times rate instead of discount rate. So this is the alternative to how to shorten the query and etc. Those the other thing is often when you access basically retrieve the record etc. You would like to sort the result, right? So it's we are human. We need to use a pattern. Like when you register today, you have to go to use your surname, right? Use the surname, and then so that we easier to find out your path and etc. So similar thing for sorting. So basically, you can do an order by and ascending order or descending order. So here you can do a order by price, descend, and then like a second one, basically if the same price, and then use the ascending order name. So this is the the other way to do the sorting. So basically you do order by, so basically the price. So basically previously basically the name, the method name is extra long. If you use this annotation, so basically it's order by, you can say by the price and then as descending, and then order by name. Basically is ascending. So you can say just say find by name, name like this, and price between this, and then you can later on you can just sort them. And then is the here you use the annotation. Alternatively, you can pass in the sorting here. So basically this is a var-args. And then you can do the first sorting by price and then sorting by name. So it's, the other thing is also trying to fix the method name pattern. Basically, sometimes it goes too long. And the other idea, basically, we prototyped in OpenLiberty, but has not been made to the Jakarta Data spec, is you can even use any arbitrary the method name. However, you put all the things as an annotation, basically filter, and then basically filter result, and then basically order them. And then you can even go extra miles to do an update as well. And then you can do the update, this operation multiply. So it's multiply by this rate. So the other thing is when you kind of retrieve a lot of record and etc. You know, it's kind of the in the Java streaming, and also you just limit I mean how many things you want to retrieve. So similarly, so you can limit the number of results. Just say find the first 10. You also name alike. So this is kind of the first, and 10 is first against the kind of the reserved keyword, and here you could be any of them for the find the first one. So this is just a number. And then here you kind of find by name like this, and then later on you just say the result order by this. So basically the combination between the basically the naming convention and also the annotation. And then another alternation is basically you can do the limit. Basically, it's the same as basically find the first 10. So here you just find the name like this for the first 10. So next thing is previously I talked about when you just retrieve the record and etc. You get all of them, right? It's not a good performance, not good for performance. You really want to read one page and then another page and then another page. So this is called pagination. So it's a pagination. There's one pagination is called offset pagination. So basically, you just say, okay, you find a name like name pattern, and then price between this main price and a max price. And then I said, okay, I define a pagination. So basically, this one, it will read page by page. And then when you call it, so basically, you can specify the size of the page. So basically, each page you have a 50, just read the 50, and then you go to the next 50, and etc. But one potential problem is with this style, basically you just, okay, one page 50, another page 100, and then 150. Once you manipulate the record, you do the add or delete and etc. And then this will cause the problem. You could kind of lose some record. If you delete, if you add things, the first 50, and then actually and then shift to maybe the 50 is shifted to be 51 if you add one record. And then you basically you duplicate this read. And a similar thing for delete. Delete, if you read the first 50 and you delete 2, so basically the next page, the first 2 is shifted to be the first 50. And then you miss some record. So this is kind of the, once you do the more, manipulation of the record, and you potentially have this kind of a missing record or duplication record. So that's comes with the key set pagination. So key set pagination basically you introduce a pointer. Do you do C++ before? Okay, just a few. So it's one thing, good thing with Java is it doesn't have a pointer anymore, right? So when I learned C++, is do my heading all the pointers and etc. But in the key set pagination, it uses the pointer to point at the end of the 50s, point to the 50s kind of that record. So no matter whether it's add any method or delete any method, so next page, it will go to read the next record after the current, the cursor. So this is kind of key set pagination. So the implementation point of view, so all you need to return is the key set aware page. Instead of page, you just return that. And then it's all the rest are exactly the same. So it's for the implementation. For the key set pagination, basically, it will just first do the filter, and then do the order. So that's it. And then it's the kind of implementation is the kind of at the end of page. So it will write down So basically, so here the selection last name, first name, and also the ID. It will just directly point to that very record. So uniquely identify that record. So in this way, it always the next page is after the current record. So this is a quick run through of the Jakarta data. So to kind of the recap, so the Jakarta data basically is 3 key elements: entity, repository, and then your REST application. So basically, is you define your entity, you define your all the interface repository, and then you just call the repository method to go with it. So I will give you a quick demo. So on Open Liberty, so we use implemented Jakarta data. So it's as you see how easy it is. So I have my VS Code. So basically, can you see? Yeah? See? Good. So basically, it's for the entity here. So I use this is use JPA. Yeah, JPA, and also you use beam validation. Do you know beam validation? Anybody? Yeah, this is often JPA always best practice. Go with beam validation. So also demonstrate it kind of works quite nicely with beam validation. Any of you use JPA? JPA? Great, awesome. So you can see the beam validation, all this kind of the pattern. So basically non-empty for the name, and also the rank need to be captain, officer, engineer. And this is CRUD ID. So basically it has 3, the name, rank, and CRUD ID. So this is as simple as that. So this is entity. So the next one, I define my repository. So this repository, I use a data repository. Remember, data repository has no method. So I just add my method. I use the naming convention, find by, rank. Yeah, so I supply the rank, find by. Here, I find all of them, and find all of them I can order by name. And here, I can do a delete by CRUD ID. So this is very important. Here, delete by, after the by, so this is the kind of this is the name. The name is basically the entity name. So we know in that entity we have CRUD ID. We know in that entity we have rank. Need to be exactly like that. So it's basically you use the kind of uppercase the first letter, and then you can do the save. So basically save that. So this is the kind of the second class. The second thing basically the key element is a repository. The third thing is the REST. For the REST, the major thing you inject that crew member, right? You inject, and then you can also inject the validator so that you can print out if something is not working, print out why it's not working. And then you can do the add. So basically, you add the crew member. So here, you do the validation first. Yeah, if something is not working, you print out the message why it's not working. And then you can see the beauty of it. I have no implementation of the crew members. I can directly call crew members.save. I save that like a record. And then I can do the delete. I can directly call the delete by CRUD ID. And then I kind of do the retrieve. So basically, I retrieve all the kind of record, find all, and then it's kind of the display. So here I retrieve it by rank. So I retrieve, call the method basically find by rank, and then I print it out. So it's basically this get operation, and then delete operation, and then post operation. So it's very simple, and then it's running on Liberty. So it's basically anybody use Open Liberty? Okay, I feel. Yeah, great. Anybody who have heard of Open Liberty? Okay, that's good. If you have not used OpenLiberty or have not heard of OpenLiberty, go to check it out, openliberty.io. OpenLiberty is IBM open source runtime for both MicroProfile and Jakarta EE implementation. So here is the beam validation. And then in this demo, basically is use the Postgres. So basically it's a Postgres. So in here, basically, I already have the Postgres running in the Docker. So it's basically and also it's also already got a test DB like a database connected. So it's if I go to here, so it's all already running. So it's running here. So I can add basically 8. I add my name. I'm a captain. And then you can see it's the kind of all displayed there. And then I saw a tab view there. So here, the captain. So this is all kind of listed and etc. So this is kind of this is JavaScript. So it directly lists call the find all, and then find all of them. And then here is directly calling find by rank. So it's a display of the rank. So it's kind of as simple as that. So it's if you want directly adding any other method, for example, basically you just say for a crew member, you can just say and then it is found by crew ID, and then you can pass in string crew ID. So this will be able to find by crew ID. In your CRUD, you can directly, in your REST call, you can just directly call it to display the ID. So it's basically I show you how to get it started, and then here is basically here is JavaScript. So you can see is how it's displayed. So this is kind of the these are all the basically all this example is available on the OpenLiberty sample Jakarta Data, so you can fork it out and basically try it yourself. Let me quickly go back to the slide. So this is basically it's a recap. You have an entity, you have a repository, and you have a CRUD service. And this is a link. So the top one is a sample, and then is the other one is I demonstrate a Postgres SQL, and you can also try it out the JNOSQL, and also this link is Jakarta Data link. So for preparing this demo, and there's quite a few people contribute this. Basically the Michael Simmons, Jean Tessia, Steve Bass, and my colleague Nathan Raw and Mark Swartosh basically helped with all this demo and slides, etc. And most last but not least, Ottavio Santaza. So it's later on he will do Ottavio will do another talk about data access as well. So with that, I think this is the end of this presentation, as I mentioned. And tomorrow I have another talk, monolith to serverless talk, and it would be great. You can also join me there. Thank you so much. I think that's all we have time for. If you have any questions, approach me and Werner to discuss further. And this is our Twitter link. If you kind of if you like later on find any questions, just ask there as well. Thank you.